Today's session will cover an overview of our generative AI strategy, showcase some examples of how it has been used successfully, and provide a demo of how it works with our current toolset. And with that, I will hand you over to your presenter today, and Andre is going to kick us off. Over to you, Andre.
Awesome. Thanks so much, Karen. Thanks for having me. It's really a pleasure to be able to talk about some of the new things we are seeing when it comes to generative AI, especially on AWS. And today, you probably have seen, but this is me as Dr. Strange, and that's going to be one of the demos that I'm teaching you today. I'm going to use some SageMaker notebooks to do some Stable Diffusion fine tuning so that you can understand what the process looks like. But before we can get started and get our hands dirty, I just wanted to walk you guys through the topics we are going to be talking about today. Today is going to be a deep dive session, tech session, in-depth discussion on some of the key topics, like what we can do to get started with generative AI on AWS, what the options are, including using Bedrock, SageMaker Foundation Models, Code Whisper, information and training. And then I'm going to discuss some of the best practices for designing generative AI applications, including things like how to implement VectorDB, semantic search, how to implement your interface, how to orchestrate the conversations between your app and large language models, some of the tuning strategies, and then we're going to have 5 demos where I'm going to talk about things like generate image from text. We're going to do some fine tuning and domain adaptation. We're going to teach you how to use some of the SageMaker SDK for financial data to train a GPT model. Then I'm going to show you the playground we have at the AWS console that you probably already have seen, and also how to create your own one using Streamlit, right? And then to top it off, I'm going to talk about how to implement RAG using Kendra, OpenSearch, and the embeddings available, embedding models available within SageMaker. So stay tuned because this session is going to be, we're going to be talking about, and there will be a lot of demos. Just as a recap, I just wanted to walk you guys through on what are the options to get started on generative AI today, right? So first and foremost, you need to remember that there are some options. So we have those that need to train your own model from the scratch, and usually this is more suitable for a use case where you need to train a model with 200 billion parameters, features, and you have a huge amount of data, and you gotta have control on things like number of tokens, size of tokens, and everything. So when you have to have that sort of control, that's the type of approach you need to take. On the other side, you may leverage some of these huge large language models like the Bloom or the AI-21 Jurassic, and there are so many others. There are Llama from Meta and many others that are available. And then basically what you need to do is to fine tune to teach that model to be able to answer specific questions to a domain. So let's say you wanted to implement use case around medical interaction where a doctor or patients are looking for information on their clinical records, for example. So you teach a model to interact with the patient. Or let's say you wanted to teach a model to provide financial advisory for clients, right? So that's a way to do that. And also, you may, for those that are just wanted to consume an API, you can access some of the previewed models, and also you may be able to fine tune by providing some labeled data set, not a huge amount of data, just a sample with hundreds of records may be enough. I'm going to talk about a bit of this. So, but just as a reminder, we need to understand the roles and skills in generative AI. So we have the model providers, model tuners, and model consumers, right? So when it comes to model providers, we are talking about a skills requires deep end-to-end machine learning and natural language expertise in data science to be able to leverage some of the techniques to train your model, to compress your model, to do data parallelism, to process your model against a cluster of GPUs to train your model currently. When it comes to tuner, we require some strong machine learning expertise to apply fine-tuned techniques, prompt engineering, RAG, which stands for retrieval augmented generation. And then for consumers, it's just a matter of calling an API. So these are the topics, the key, the three items we need to keep in mind when we consider to design an application. Whether it's going to be a provider or a tuner or a consumer, or eventually based on the use case, we can mix and match. I'm going to talk about those options. You probably haven't heard about some of the new AWS offerings for generative AI. For example, the Amazon Bedrock, which was announced in April 13th, which is the easiest way to build generative AI, which provide access to the most comprehensive and open foundation models such as Anthropic, Stable Diffusion, and also Titan, which is the foundation model that's going to be provided by Amazon. We had Code Whisper, which is a platform to accelerate developers and improve developer productivity by providing a way to implement functions, methods for a class. So let's say you are a Java user, and you are developing using Visual Studio Code, and then you are developing an application that needs to access an Oracle instance running on top of Amazon RDS, and then you need to insert a record, create a file in an S3 bucket, and then by simply providing comments, it's going to create methods and all the things. And not only for AWS services, but you can ask, create an array of integers and create a method to sort this array. So you can name it. So there are multiple ways a developer can leverage the Code Whisper based on the platform he provides. And also we have provided training and inferential, which are purpose-built accelerators, which are key for those customers looking to train their model from scratch, or also for those that wanted to do some fine-tuning, or domain adaptation, which requires some additional training. Eventually, you may not need to train from scratch, but you may need to train from a pre-trained model, right? I'm going to discuss some of the options. But just as a quick reminder, Titan comes with a Titan text, which text-to-text generation, and also embeddings, which is a service which provides a numerical representation. And this is a key point when it comes to search, when you want to implement search capabilities. And we are doing and we wanted to implement document relevance. And also we need to categorize our documents based on a prompt or an input we are providing when we are creating our generative model. And on the other side, we have Jurassic 2, Anthropic Claude, and Stable Diffusion. So these are the models that you can pick up from Bedrock, to start by simply calling an API, you have access to all of this. We have Titan Tax, as I mentioned, which is focused on natural language processing tasks. And also we have Titan embeddings, which is key when you're implementing some sort of functionality. For example, RAG uses a lot embeddings. For example, during the demo today, I'll be using Kendra, which streamlines the process doing this uh, doing this RAG implementation, because sometimes you need to do with data chunks, and you have to adapt to the size of the token, and Kendra manages that directly. And same thing with Titan embeddings. But I'm going to show you some of the different options, and you may combine with some open source tools. So the point is, with AWS, we are flexible. We wanted to democratize generative AI, and you may combine with many different options, which fits better to your use case. I spoke about some of the models we're going to have. I'm going to show you this while walking you through the playground within within the SageMaker console. We have Anthropic, Stability AI. So these are some of the models we have provided. And as I told you, uh, Bedrock also provides a way for you to fine tune and to adapt for a specific purpose. So when it comes to generative AI, you can do one single model can do many things. Like you can do summarization, text extract, sentiment analysis, code generation, and the list goes on and on, right? But sometimes you need to fine tune for a specific domain. For example, financial services or healthcare or retail, and you wanted to train that model to answer questions based on documents, unstructured documents that you may have within your company, or eventually you can compile information from your ERP systems as well as CRM, and or even providing an API where you can pull data and train a model. So you can do that with Bedrock, with SageMaker Foundation Models, and the point is that we wanted to provide a flexible platform that adjusts to your business need and your technical requirements. So this is the AWS AI ML Stack, and I wanted to call, you have seen these three layers, right? Provider, tuner, and consumer. So we have basically these three layers and the types of needs, right? So providers, tuners, where you wanted to use SageMaker foundation models, and consumers, where we're going to be using some of the specialized AI services like Forecast, Kendra, Personalize, Cold Brew, OpenSearch, and things like that. And on top of that, these are pretty much the new services where I'm highlighting on this is like that. Some of the new pre-built models in SageMaker, training information that I just spoke about. This is only a summary because you probably have seen some other sessions. But the point today is that I wanted to spend time by talking about best practices as well as showing you a demo for each of these courses. So you're going to see, for example, SageMaker Foundation Models working with Kendra, which is a AI service for RAG. You're going to see a Jupyter notebook for fine tuning, where I'm going to be using the SageMaker SDK for financial services to adapt that particular model to be able to answer questions on the financial services domain, right? So there will be a lot of different things, but for now, I just wanted to walk you through. So again, the Amazon SageMaker Jumpstart is a collection and catalog where you can browse those public and proprietary foundation models. You can experiment. For example, even some of the new large language models that were added to Hugging Face are available there. So you have the Llama large language model. I'm going to show you while walking you guys through the SageMaker console. These are some of the models, the key models we have over there. So Stability AI, Alexa, some of the Hugging Face, including Flant T5 and all the variants. We have the Blue models, Coheed, Lidon, and AI 21. And look at the bottom, which provides some of the key tasks where these models performs well, right? Performs better. So, for example, whenever we are talking about those Hugging Face model, we may use them for things like data generation, summarization, Q&A, machine translation. So there are a couple of tasks that each of these models performs better. And on top of that, we may combine with some of the techniques that you're probably familiar with, like, for example, prompt engineering uh, and RAG, as well as reinforcement learning with human feedback. There are three ways you use the foundation models. Today, I'm going to walk you guys through all of them using the studio, the notebooks, and the console. So you're going to see demos across all these three different flavors. But for now, that I walked you guys through and I provided an overview on all the AWS options based on the AWS AI ML stack. I just wanted to discuss uh, some of the key things we need to consider while designing generative AI applications. So when it comes to creating a solution, it's not about only to use a large language model, but is to consider things like how I'm going to implement my user interface. I'm going to have an API. How will you control access to the model? How I'm going to be charging? I'm going to be charging if I wanted to create a solution to provide to other clients. So here is a summary on things you need to consider, right? I need you to think about data ingestion, data processing, labeling, developer tools, fine-tuning models, accelerated computing and infrastructure, machine learning platform, which vector DB I'm going to use. I'm going to use text embeddings or not. What is the front end? Front end is going to be a mobile app and things like that. And I just provided a summary on some of the key services like AWS Services Mapping for each of these key steps when you are implementing a generative AI solution. So, for example, for data pre-processing and labeling, you may use some of the services like EMR, ground truth, and data handler, for example, for the data ingestion. You may combine with some of the open source tools like LangChain or Streamlit for front end, or you may use AWS Amplify. Or, for example, to create your Q&A or your chat, you can use Amazon Lex. So there are multiple options you may use. For example, today we're going to be exploring with VectorDB for semantic search, which do that with SageMaker KNN or OpenSearch, right? Or when it comes to text embeddings, we can use also some of the models available through SageMaker Jumpstart, for example, GPT, J6B, or Bedrock API. So there are many options, and you can combine according to your technical needs and your use case. One additional thing that is also worth mentioning, it's about the generative AI ecosystem, right? So when it comes to applications, there are many options. You can create chatbot or Q&A knowledge. You may be considered to create a coding assistant tool. For example, let's say you wanted to migrate COBOL applications to Java, right? And you can use one of these models to do some sort of a migration. Or eventually you wanted to do image generation using the Stable Diffusion. There are many options. These are pretty much the key use case for the application. And when it comes to the back end, you're going to have the machine learning infrastructure to be able to train your models or to do some fine tuning. We're going to be training based on a pre-trained model, or where they're going to need to deploy your large language model, your foundation model, to be consumed like we do with SageMaker endpoints and using the infrastructure to serve inference, right? And then you have your foundation models, and the tools that you're going to be using are developer tools, prompt tools, some performance metrics, embedding vector DBs, and the list goes on and on. But these are the key things we always got to be in mind, right? So this is the we could call like the reference architecture for when developing applications, right? So there's key elements I showed you with that flying wheel and the type of application we're going to be implementing. But how do I access foundation models on AWS? Probably have seen you have two options: Amazon Bedrock, which is by simply calling an API, it's a serverless option, and on the other side, you have the foundation models, which we are going to be deploying using SageMaker training and inference, using any endpoint, and you can pick up the options you want from the catalog, right? So, and then on top of that, you can apply some fine tuning techniques, or you can change the instance you're training, and you can use parallelism, things like that in case you need to train from scratch. So you have flexibility to do that, but accessing existing foundation model, that's are the options. So using an API layer or using SageMaker endpoints, which access that huge catalog. There are advantages for each of the approach based if you are a consumer or if you are a tuner, and based on the control you want to have, right? That's a key point to consider. When it comes to customize a foundation model, what are the options? So let's say I have a prompt against a foundation model that was trained against Wikipedia books and a common crawl over the web. And then the question, which foundation models are supported by Amazon Bedrock? And let's say the student doesn't have an answer. So I may need to train. So specific tasks I need to, for example, to do closed domain knowledge, things that I have mentioned. And doing that, customizing foundation model also reduce the likelihood of hallucinations, right? So when the model is producing something that doesn't make sense or is not aligned with the type of prompt I'm providing. And how can I customize a foundation model? So there are basically three ways, and we're going to be exploring that. We have prompt-based learning, which is a supervised learning, or which goes by the name of fine-tuning. Sometimes you may hear about knowledge transfer. Basically, it updates the model weight. That's the secret sauce. And it trains against a small amount of data using the JSON-L format. It doesn't require a lot of epochs to train, and there are some models that support fine-tuning. I'm going to show you during the demo, but when you log into the SageMaker studio and you are browsing the foundation models, you're going to find out there are like an indicator which says which foundation models support fine-tuning, right? You can do some sort of domain adaptation, which is a kind of variation of this fine-tuning, where you have this CSV, JSON, or text files. That's the one that I'm going to show you during the demo today, right? I'm going to show you how to do that. And information retrieval, which is also known as RAG, augmented retrieval, right? So you use, for example, an external source of information, like could be your database, API, and you combine that information, you turn that into embeddings to classify and to do semantic search to see to provide additional context to enrich your prompt, which will increase the likelihood of a more accurate answer. Some use case, as I mentioned, for example, retrieval augmented generation, document summarization, and document generation with facts, right? So these are the key use case we are seeing. I'm going to show you a demo about that. But before we can drill down into the demos, I just wanted to provide a guidance so we have around selecting the right model. For example, the first column here, you can see that we have activity tasks like summarize, classification, question answering, code generation, content writing, copywriting, the list goes on and on. And based on the specific use case, we can pick up one of the models. So let's say I wanted to do some content writing, like blog post title or a blog post outline. So one option would be to get the Coheed Common XLOR model and use this for this particular task. But you may use other options like the AI21 J2 Jumbo Instruct, for example, or you may use Bloomsy, which is a 176 billion parameter. So there are multiple options to address the same use case, and this is pretty much a recipe or a guideline on how to do that using the SageMaker platform. So, but generally speaking, as a guideline, all the models, including instruction tuned models, performs better with few shortcomes. So I'm going to talk about that in the next few slides. And this is a summary on things like the type of model based on the size and the complexity. So for example, let's say you need to do some instruction tune and you wanted to use with zero shot, and you wanted to pick a flant T5 X large or a flant T5 double X large. That's going to be used ideal for smaller instances and faster inference times, right? When we need to do some text completion, where you need some few shot, we have other options. And this is pretty much a guidance on how to do based on the number of parameters, the complexity of your queries, and the type of model you need to pick up, right? This is a really important thing to consider when you are designing your generative AI application. The model you're going to pick up and the reference architecture are going to be used, including the frameworks I just mentioned, like LangChain, VectorDB, and many other areas. So I wanted to talk about some of the tuning strategies I briefly spoke about then. When it comes with tuning strategies, there are basically three, right? Pre-training, fine-tuning, as I just described. You create a model from scratch, and basically you're gonna need to acquire a large data set. You're gonna need to format, cleaning, remove data that to reduce bias and things like that. And sometimes this process takes like weeks, to not say months. But the advantage is that you have access, for example, to the vocabulary size, context length, the training data, and you have basically full control. On top of that, you have fine tuning, which is something that I'm going to teach you. I'm going to show you a demo. You have prompting techniques like zero short learning, few short learning, and one short learning, right? Usually those huge models, they're going to need a few short learnings or eventually combine with other techniques like reinforcement learning with human feedback. For example, everybody knows about ChatGPT and they know the way OpenAI has used to train. They use this technique a lot to be able to provide more accurate answers, for example. And there is also instruction tuning, which is this technique aims to teach language models to follow natural language, including prompt, positive or negative examples, and some of the constraints to perform better multitask learning. This is one because it learns from multitask learning on training tasks and generalization on unseen tasks, right? So, for example, let's say your model is not good at doing sentiment analysis. With this instruction tuning, they're going to be able to cheat that. This is a way. This is a different approach. But let's talk about prompt engineering. So prompt engineering is very straightforward, as the name implies. It's a technique to provide additional context to your prompt, right? So that's with this in mind, you're looking at provide additional context for your large language model to be able to provide additional information or a more accurate answer. For example, this is an example using a task description, which is sentiment analysis. We have provided like 2 examples, and based on that, the third request is to say, I enjoyed this movie, to say whether or not this is a positive feedback. Now, of course, it is, but this is a way to teach the model, because at the end of the day, your model needs some guidance to be able to provide more accurate information, and this is a way to do that. So basically, there are 2 ways to work with prompt engineering types. So you can prompt instructions where basically say, write an email, thank your team members for successfully organizing community meetup, which is a generic thing, and maybe you may need to provide some additional things. Or on the right side, you are prompting by examples, right? For example, given a product and keywords, this program will generate exciting product descriptions. So basically, this prompt is teaching the model to create product descriptions. And then we provided 2 samples like monitor and surfboard. And then we are asking to provide product descriptions for headphones, including keywords such as Bluetooth and lightweight. These are the things. And based on that, your model is going to be producing. And then this is one of the things that we're going to see while doing the demo with the playground. I put together like some examples based on the different type of models we can use. For example, with short learning, 0 short learning, few short learning, 1 short learning for each of these models. So there are some syntax, the syntax is specific for each of them. For example, the Alexitn, you're going to see like the CLN, Oracle. This is a way to integrate with that. This is only a sample, of course, and we're going to spend some time doing with this during the demo. Prompt-based learning, as the name implies, is to provide some additional context, but this, unlike the in-context learning that I just mentioned, is done during the training, right? So unlike traditional fine-tuning process, which requires labeled data and some additional gradient updates and weights, as we are doing with fine-tuning, the prompt-based learning allows the model to adapt to different tasks by transferring knowledge from the prompts. And this is applied during training, right? So one important topic to mention, why business need fine-tune large language model, right? So for example, we may need to adapt for a specific business need, as I just mentioned, and we have a large and labeled corpus, and we need, for example, to adapt that model for additional context. Here is one example, right? Using the GPT J6B and some other varieties. This approach, this process is used usually when we have unlabeled and tuning is not a task specific. For example, you can see we have what are the key elements of a contract. Using the original model with GPT J6B, we have this answer. And then when after providing some additional context using the text file, that's the answer. So by simply using the Jumpstart UI, you are able to implement this, and also we have the ability to do it with the SDK. This is one of the examples I'll be showing. We also have some task-specific text-to-text fine-tuning. For example, the flant T5, different we have different flavors, and they are for used for task-specific, right? So sentiment analysis, entity recognition, text summarization, machine translation, and things like that. So on top of that, we may require some additional prompt engineering, but we have these models we can use for text-to-text fine-tuning based on the natural language processing task. And as I mentioned, we can use retrieval augmented generation, which goes by the name of RAG, to connect to an external source, which can be a database, a repository of files, CRM, ERP, or maybe you can mix and match information and you can merge from different source. And this will be used to provide additional context. And I'm going to show doing this during the demo, but this context will be added into the prompt we're going to be providing. And I just, before we get started with the demos, I just wanted to provide some additional, some RAG architectures we can use. For example, in this case, we are using SageMaker real-time endpoints for the embedding models and open source indices, right? And then user ask a question against the model, embedding models, which search, open search, and provide additional context. And then those additional contexts, like context 1, 2, and 3, is used to in conjunction with the question, which will be sent to the large language model, which is available and deployed on SageMaker, right? And then the answer is going to be more accurate. And also you can you can use some prompt engineering techniques to say to your large language models to answer questions only based on that data information you're going to be provided. So in other words, if you don't want your model to answer questions outside your company documents, you can teach your model to answer only based on the context provided. So with some prompt engineering techniques and additional, and on top of that, with RAG, we are going to be able to provide super precise answers with the models. There is a different way to do that. You can use, for example, in this one, we are using FAST, which is a library developed by Facebook AI for efficient similarity search and clustering of dense vectors. So you can use OpenSearch for that, or you can combine KNN and FAST to provide that context. But overall, the approach is the same. So basically, you have the option to use AWS services as well as open source tools. And on top of that, if you wanted to do everything within SageMaker, you are able to do that. And this is exactly the demo I'm going to show you using LangChain, FAST, and RAG approach, right? So this is the demo I'm going to show you as well. But I wanted to show you there are multiple ways to do this. For example, you can provide all of your enterprise documents into a repository, then use SageMaker to index all of this data and create like vector DB. Then you post the question, and that will be providing, be outputting some additional context, and then you can request, you can create a prompt including question plus context for a more accurate answer. And this is a way for you to implement also short and long-term memory. For example, when you work with ChatGPT, you're going to see that it learns, it provides a history of questions you ask and have additional context. And this is a way to do that using SageMaker Foundation Models, as well as using OpenSearch for long-term memory and for the custom domain knowledge, using the embedding store, as well as DynamoDB for short memory, using for the conversations and the sessions we have in place in case you want to do a multi-turn chat application. This is a way to implement that. And now it's time to roll up our this is enough talk, and let's get started with the demo. So first demo is going to use the Coheed model, which is available within the playground. This is really straightforward. Let me go to the let me go to the SageMaker Foundation Models, for example. And then, as I mentioned, there are many models available so that you can consume it right from here, or you can do that using the studio. For example, I'm going to use Coheed, right? And then you can open the model and see all the details about Coheed, what it looks like, some of the highlights, details about this, and then the playground. With the playground, I can open the prompt and change some of the parameters like number of tokens and temperature, which will say how the model will provide the answer is going to be more creative or not. And then I'm going to use some of the tasks I have here. So let's say I wanted to do a zero short learning like this, right? And then I wanted to create a marketing blurb for new sneakers. And then based on that, you can see the output. So it's really straightforward. But let's say now I want to do a text summarization where I provide this huge text, and then I go back to the model and say, please summarize this text, me. Basically says the spirit of Saint Teresa is one of the passionate, ideal nature. This is a summary of this text. And now what I want to do is basically to do zero short learning, but with some additional context. Let's go to the model. So the question is, what is the mission of the United Nations? And here is the answer, right? But on top of that, I can do some few short learning. So it's a different context, right? So I ask questions around authors, and then I ask them to extract entities, named entity recognition. So I'm gonna do this. And I asked to extract the entities. And here we go. So this is really straightforward, nothing different, no big deal. But now I wanted to spend more time on the technical aspect of those demos. For example, now I wanted to teach you how I did the image generation using Stable Diffusion file tuning, right? Basically, if you go to this one, hopefully you guys can see it. This is my, I use one of the SageMaker Generative AI examples. I'm going to provide all the links for you to be able to do it yourself. But basically what it does is to import some of the libraries, then update the data. And just so you know, I use like 9 to 10 pictures I took myself, or like with a few selfies, as you guys can see here. I use some of these pictures to train my model, right? So only 9 to 10 pictures. And then I used this JSON file to provide a new class prompt, like Andrea, right? And then once I finished that, what I had to do was to do this fine tuning, which required some additional tuning, right? So I used this model ID, Stable Diffusion, which is available with foundation model within the SageMaker Studio. I used this training instance, then it took some time to train, but I'm not training from the scratch. I'm just training against this model that I just provided to S3. And then I deployed this using my fine-tuned Stable Diffusion model, which I just created. And then this is a training, which is, well, you can see all the details. And now I have deployed the fine-tuned model as a SageMaker endpoint. No, super simple. You're gonna see that this take a few minutes, like 10, 12 minutes to complete. And then once, yeah, it took me 12 minutes to deploy this. And now, if you guys look at this, you're gonna see a picture that I just generated, right, based on these images. If I ask again, I can just run this model and say, I want to see a new picture of Andrea as Doctor Strange, Marvel Cinematic Universe, 8K photo, right? I can do that again. It's going to take like a few seconds to complete. I'm not sure about what the answer will look like, but let us try with a different prompt. So let's say I wanted to do Andrea as Captain America, for example. And this is Andrea as Captain America. Hopefully, not sure if I'm gonna need to fine tune or to train more. It's going to take a few seconds. Like that, right? But these are some of the samples I did. I took a few screenshots, right? Using the same technique. Andreas, Doctor Strange, and that's the one that I just used to create. This is very, very simple. But let's say you wanted to do something more specific. For example, you may use and you wanted to do, you have a prompt database. This is not with AWS, but this, you're gonna use millions of prompts. For example, so let's say you wanted to do something with Spider-Man. You can use some of these prompts to tune your model. And that's what I did. I use this prompt database, which is available public, and there are many others. This is a way to do that. And you can pick up, for example, Andrew as a Spider-Man, or ArtStation, superhero concept art, hyper realism, and ArtStation. And this is a huge database using a Stable Diffusion model. This is one thing in case you wanted to give it a try yourself. Let's move to the next demo, which is around domain adaptation fine-tuning of financial data, right? Let me provide more details on what the process look like. For example, you may need, let me open up. This is, by the way, it was based on this blog post, right? Which use SAG filings of Amazon from 2020 to 2022, if I'm not mistaken, and use the Python SDK to train your model. So basically what it does is basically we pick up some of the examples right here. What drives sales growth at Amazon? Amazon is the world's largest online retailer, and we ask these questions, and we use the SAG filing data set to provide additional context so we are able, for example, when we ask the question, this Form 10K report shows that, this is the answer that is provided out of the box by the GPT-J6B before fine-tuning. And this is after fine-tuning. And you're gonna notice that this is more detailed, more accurate, and more precise, and provide additional context to the Amazon information. So going to the fine-tune, sorry, this one. You're gonna see that, for example, let's go to the Amazon readings, Jumpstart, foundation models, train data. This is a sample of the train data. As I mentioned, it's a text file from the SAG filing. This is a public document that we used to train this model, right? So basically the process is the same, to use all the libraries, then select the text generation model, run inferences on the pre-trained model without fine-tuning to show the before and after. So the queries we use are, our vision is we serve consumers through to provide more details on Amazon. And this is the output, right? This Form 10K report shows that the company adopted effective March 1st, 2008, and things like that. And this was provided by the GPT-J6B. But when you scroll down, we clean up the endpoint, and we start with the fine-tune with a pre-trained model using a custom data set. And the custom data set is this train text file, which we downloaded from that public repository. This is a sample, and we basically retrieve the training artifacts, setting the training parameters, and after that, we do some sort of hyperparameter tuning using HPO with SageMaker, and they start the training, which take minutes to complete. And once the training is finished, I'm sorry, this one took like almost an hour. Let me scroll down because it's a huge one. And you have your training job. For example, if you go to SageMaker training jobs, this is a training job we used for that particular. That's the one, right? And it provides the details on the instance type we used. For example, GPT, the model type, the instance type, we use training and things like that. Let me go back to the, I need to reload. Now that the model has been trained, basically we extract some of the additional metrics, and I used this for inference, a ML G5 24 extra large. Could be 8 extra large or different. I just use this to be really fast. And this is the answer, right? As you can see, this form taking report shows that includes share subject to repurchase. At the end of the day, it's using more details. So we teach the model to be able to answer and provide more additional details. And this is a way to do fine tuning with domain adaptation and by using the SageMaker SDK. Going back to the demo, one of the things that I wanted to show you on top of that, the prompt engineering playground. Basically, we have many different models, and here we use stringlet to create an interface to test our models, right? For example, if I pick up this one over here, proxy, then you're going to be able to see some of the models that I deploy, right? So we can pick up, for example, the flant 5. Here are some of the parameters, and we can ask questions to it. For example, pizza comes from Italy, burger comes from USA, curry comes from India. And I can change this, for example, let's say we are a traditional food from Brazil, which goes by the name of feijoada. Brazil. And we can try different things, right? So the purpose here is to say that you can deploy your own models using SageMaker and using an additional interface where you can play with your prompts. For example, let's say I go to this foundation model and pick up Plan 2.5 and ask it to do a summarization. Or question and answering, or let me pick up this summarization. If I go to here, I can ask this model to do summarization for me. So basically, two statements, one phrase on what Amazon comprehend looks like, and it works. And we can try this against different models, and you're going to see that the answer is going to be different, right? Eventually, we're going to need to do some prompt engineering techniques. But the purpose of this is to have a playground where you can try. And here you see the input, and this is the output, right? This is a way for you to train the models you train with SageMaker. Going back to the studio, you're going to see that we also have, of course, the home. We can see all the jump starts, and we can look for example, solutions. We want to see foundation models. And look at this. Some of them says, for example, Flant 5 is a fine-tunable, which says yes. Alexa TM is not fine-tunable, so you need to pick up the ones which are fine-tunable to fine-tune your model against that. GPT-J6B is fine-tunable. BlueZ as well. We also have the recently introduced OpenGamma, and you can view the model, right, as well. This is a good thing to see. And proceeding to the demo, just to finish with the last one that I wanted to show. The next one is about a RAG. And this is a reference architecture. So for example, we can use text extract, comprehend, or SageMaker processing for doing intelligent document processing. In this case, we're going to use SageMaker processing, combined with Kendra, which is indexing a repository of invoice. So I'm implementing an invoice analysis application, and use Streamlit with a LangChain to provide the user interface where user is going to be interacting with. And then is going to ask questions against Flant T5 double XL model. So let me show what the process looks like. So let me go back. For example, the first thing I wanted to show you is that I created an index with Kendra. And then within this index, I have some data sources, right? I have a web crawler, which points to a couple of websites. And also I created this particular one, which is pointing to an S3 bucket, which has hundreds of sample invoices, right? If I go, for example, to S3 over here, you're gonna see I have indexed in crawling Kendra with these invoices. So as you can see here, we have hundreds of invoices that has been uploaded, over the 1,000 actually, which I use to train. And then what I'm gonna do is basically, I'm going to ask Kendra, let me go to the application over here. I'm gonna go to this terminal. And we have this sample application, which I'm going to post over here, samples. And this is a Streamlit application, right? I can show you and you can spend some time. But basically what it's going to do is that this Streamlit application, we restart this integration for the RAG application. For example, now I'm going to reload this page. And here is the app, right? So I'm going to ask, for example, what is the client name on invoice, on a particular invoice? For example, in this case, the client name on invoice 6135 6291 is Rodriguez Stevens. And here are some of the sources he used. So it says it's on invoice number 1. And if I go, for example, to Kendra, you're gonna see that if I do a search index document, for example, it's going to bring that particular one and it's going to highlight some of the things. And then I can double click here and zoom in, and you're going to see that the client name is Rodriguez Stevens. And I can ask many questions: what the seller names are, what is the seller name, what are the items in this invoice. But the secret sauce to provide additional context is that within within the prompt, which is available over here, let me show you the app. This is the app. Look at this. This is really important. Really important. So this is the prompt template we use. So it says this is a following. The following is a friendly conversation between a human and AI. This AI is talkative and provides lots of specific details from its context. And if it doesn't know, it's going to say it doesn't know. And we can say it's going to answer questions based only on the context. And the context is provided by this Kendra index retriever, which is a LangChain extension, which integrates with Kendra and provides the context based on this output, right? So that's a secret sauce. And then when you see this prompt template, which is pretty much a LangChain class, you can use this to provide additional information, right? So the secret sauce is to combine different applications and do some prompt engineering techniques. And then with that, you can have some additional answers. And that's it. That I wanted to show. There are some, I'm going to share this slide deck as well, which has some of the links for the SageMaker examples I use, some direct and the GitHub repository, as well as the blog posts we use, and the domain adaptation example. Just wanted to thank you all for watching this session. Hopefully you guys have enjoyed, and you guys have a great rest of the day.